Hello student, this is Vidya Sagwekar. We'll continue with our module number 5, that is data part design. In last lecture we studied half adder and implementation of half adder using static CMOS logic and pass transistor logic. Today we are studying with the full adder. So all of you know what is full adder. Full adder is nothing but digital circuit which is used to add 3 single bit numbers. So I am having A, B and C in, and the output is sum and carry. So I am going to directly giving you this equation, that is A XOR B XOR C in for sum to generate the sum output, and for carry I am having an expression A, B, A C in and B C in. Now a full adder is also fundamental building block of any digital circuit. Now this full adder I can implement by using static CMOS logic, also as a pass transistor logic using CPL, or by using transmission gate. Today we are going to implement this full adder using transmission gates. So full adder using transmission gates. So before starting with this full adder using transmission gate, first thing is that we have two expressions, sum and carry. So in sum equation we have a XOR operation between the inputs A, B and C in. So first we'll see how to implement XOR gate using transmission gate. So what I will do, I will draw one diagram. See over here, this is just a symbol of transmission gate. If you observe here, so all of you knowing this, the input is A, output is means this is the input and this is the output. So it's having a control input. This is the control input, and this is the PMOS input. It is a control input, what is the complement format. So this is a symbol of transmission gate. All of you familiar with this symbol. Now let us implement this by using XOR gate by using transmission gate. So first I will take one transmission gate. Try to draw the symmetric diagram. So this is the NMOS input, this is the PMOS input, this is the input, this is the output. So here, see here how I am drawing the diagram. Here I am going to draw one CMOS inverter. Let's see how I am drawing this CMOS inverter. The below one is NMOS and above one is the PMOS, which makes your CMOS inverter. What is the input for this CMOS inverter? Whichever the input I am giving to the transmission gate is the input for this CMOS inverter for the gate terminal of NMOS and PMOS connected to this point. Now what is this control input? This control input I am connecting it with this point. Similarly this PMOS input, that is another control input, that is connecting to this point. Means this point is connected to the VDD of the CMOS inverter, and this point is connected with the ground of the CMOS inverter. Now what is my Boolean expression? XOR is A XOR B. So what I am going to write here? my original input is A and B is my control input. So here I am applying the A and B I am applying to in complement format. See here how B bar I am applying to the it is not here only, sorry. So here I am connecting B bar. So this is my B, and the complement of this is B bar I am applying here. So B I am applying to the PMOS input, that is other terminal of the transmission gate. Getting this, and here I am getting the final output Y, that is your TG1, and this is your CMOS inverter. One PMOS and one MOS makes your CMOS inverter.